Let's look at a couple of examples before we move on. I want to apply the quadratic formula to solve x squared plus 6x plus 25 is equal to 0. So here are my coefficients. A is equal to 1, B is equal to 6, and C is equal to 25. Applying the formula, I'm going to look for a value or two values of x such that minus 6 plus minus, and then inside the square root I have 6 squared minus 4 times 25, and all of that divided by 2. So that means I have negative 6, and then I have plus or minus, and then I have 36 minus 100, so negative 64 inside the square root, all of that divided by 2. So I need to write what is the square root of negative 64. Now that we are familiar with complex numbers, we can do it. This is going to be the square root of negative 1 multiplied by the square root of 64. So that's going to be I multiplied by 8. So going back to the x we are trying to find, this is going to be minus 6, and then we have plus or minus I multiplied by 8, and that divided by 2. So this is two options. With the positive sign, we are going to have minus 6 divided by 2, so negative 3, and then we are going to have plus 4i. And with the negative option, we are going to have negative 6 divided by 2, which is negative 3, and then minus 4i. So we found two solutions for our quadratic equation applying the quadratic formula, and I just want to point at the fact that actually the two solutions that we found are one conjugate of the other. And we are going to come back to this. This is not just a coincidence. I made a bit of space for our second example. We want to find values of a and b real numbers such that the equation we have here is true. So a plus bi squared should be the same as negative 16 minus 30i. The base of this reasoning here is going to be that we know that two complex numbers are equal if and only if the real parts are equal and the imaginary parts are equal. So we need to write a plus bi squared in a way that we can identify what the real part is and what the imaginary part is. So let's do that. Let's expand what a plus bi squared is. So we have a squared. And we are also going to have minus b squared in the real part. That's multiplying bi times bi. And then for the imaginary part, we are going to have 2 times ab. Those are the cross terms, multiplied by I. So that's a plus bi squared. And that's what I want to have equal to negative 16 minus 30i. So that means that we have two conditions we want. We want the real parts to be equal. So we want a squared minus b squared to be equal to negative 16. And we also want the imaginary parts to be equal. So we want 2ab to be equal to negative 30. We have a system with two unknowns and two equations, but it's not a linear system, so we don't have a step-by-step method to solve it. We just have to be smart and somehow find what the options could be. I think I'm going to begin by working with the second of the equations. We have 2ab is equal to negative 30. So that means that a times b has to be equal to negative 15. So I'm going to write, for instance, that a is negative 15 over b. And I'm going to substitute that in the first of the equations. So I'm going to write negative 15 over b, all of that squared, minus b squared is equal to 16, and well, we still have that a plus b has to be equal to negative 15. So this is not a problem about complex numbers anymore, we're just working with real numbers now. We have 15 squared, so 225 over b squared minus b squared is equal to 16. That's the equation I want to focus on right now. Obviously, here we need to say that b cannot be 0, a can't be 0 either. That I should have mentioned it before. It follows from the second of the equations. I want to transform my equation here into a quadratic, so I'm going to multiply by b squared to have 225 minus b to the power 4 is minus 16b squared is equal to 0. Wait a minute, I said I wanted to transform this into a quadratic, and now I have a quadratic equation. Kind of, because we only have terms on b to the 4 and b squared and independent. We can actually say, I don't know, t is equal to b squared. So the equation I have is equivalent to negative t squared minus 16t plus 225 is equal to 0. So I want to find what are the possible values for t, so we can find what are the possible values for b. Okay, I'm just going to factorize this. This is negative sign outside, and then I'm going to have t plus 25 times t minus 9. This is what I want to be equal to 0. You can check that this works. So I have the option that either t is equal to negative 25 or t is equal to 9. So b squared is negative 25 or b squared is equal to 9. Now a and b are real values, so the first option, b squared equals negative 25, it's not going to work for us. It's impossible under our conditions. So that means that b can be equal to 3 or b can be equal to negative 3. If b is equal to 3, then the value for a is negative 15 over 3, so it's negative 5. So my number would be negative 5 plus 3i. That would be the a plus bi. And if b is negative 3, then a is going to be 5. So the other option is a minus 3i. So the possible values for a and b are the ones we found over here. And you can check if you want that each of those options square give us the result that we want. If you feel you need to do some operations with complex numbers, try this.